graphing y equals minus a quarter cotangent open bracket x minus pi over 2 close bracket. The general cotangent function is y equals a cotan open bracket bx minus c close bracket plus d. Right, so the best thing to do first is to understand that what a tan function is. So tangent x is the graph goes through 0, coming from the negative infinity, it just goes through 0 there, and then approaches the positive infinity. So this is a line of asymptote, and then so that's a tangent function from negative pi over 2 to positive pi over 2. So the tan on this side will be going from there also to pi equal to pi there, and another one will be coming from this side here, so it will be exactly same as that, it's just rectangle, so it will be coming from there to there. So if you like, going from there all the way to there. So then we're going to infinity and negative infinity there, negative infinity there, positive infinity, positive infinity. So that's the time for tangent function. You see the function have a period of pi. One period is pi. Sketching the cotan function, co stands for complement of tangent. The relationship between cotan and tangent is cot x is 1 over tangent x. So now you can see when tangent is 0 here, cotangent is infinity, because 1 over 0 is infinity and 1 over infinity is 0. So we need those two information to sketch the graph of tangent and cotangent. When tangent is 0, cotan is line of infinity. So this at 0 is the line of asymptote for cotangent. So we have to draw that. So that's the line of asymptote. When pi minus pi over 2 is line of infinity for tangent, 1 over infinity is 0, so that's when tangent is cotangent is 0. Likewise, cotangent is 0 here. At pi, cotangent has a line of infinity because tangent is 0 here. So 1 over 0 is infinity. Again, so we draw the line of infinity there. So that means the line of asymptote. And also here is the line of asymptote. Okay. Now it's good to sketch it now. Good to go. So cotangent starts from here and it goes all the way down and then that way. So that's what cotangent is. So we just draw the curve. To the line of infinity there. So that's to negative infinity and positive infinity. Likewise, you come from there. So that's cotangent and that's tangent. And that's how you sketch the parent's graph. We're going to use the parent's graph to sketch that one. Well, you can see the graph cotangent and tangent don't have amplitude because it goes all the way to infinity, positive infinity and negative infinity. So there's no cap. So therefore, none. Number 2 is the period. The period is for tangent and cotangent is pi over b. B equals 1 here because the general equation of cotangent is bx. I've just got 1x. So that will be pi over 1, which is pi. Then the next thing is number 3 is the x scale. So the x scale is period that we just calculated divided by 2, because we got 2 line of asymptote for each period. So we divide it by 2 and we get pi over 2. Number 4 is we need to look at the phase shift. And the phase shift, we look at the start of the phase shift, the start, and we look at the end. So basically we could pick any point along here. We can pick that one, or we could pick that one, we pick that one. So I'm going to pick this one. You can see this is a line of asymptote. So I'm expecting to get a line of asymptote here as well with the start, because I've picked that one. That is a line of asymptote. But I set x to 0 to get that. I have to set, we haven't got x, we got x minus pi over 2, so we set that to 0. So you get x minus pi over 2 equal to 0, which implies x is pi over 2. So that's the line of, line of asymptote is pi over 2. To set this for the end, so we have x minus pi over 2 equals pi, because at the end here is pi. So that's pi. So we expect it to be line of asymptote for our function. So we set, here we set x to pi. So we have to set x minus pi over 2 to pi 2. And therefore we get x equals pi plus pi over 2. Well, pi plus pi over 2 is 3 pi over 2, because that's 2 pi over 2. 2 pi plus pi is 3 pi over 2. So that's what x is. Any vertical number 4. Do we have any vertical translation? 0, because the function we have is plus 0. So d is 0, and that implies y equals 0. That means the function is lying on equation y equals to 0. So this is equation y equal to 0. This is also y equal to 0. So that's what this function will be lying on, y equals to 0. Any reflection? Number 5. Yes, we have a reflection along the x-axis, because it's a minus here. The minus tells us there's a reflection along the x-axis. So in this case, it will be reflected down, and that will be reflected down, and this will be reflected up, and that will be reflected up. Right, so we're going to sketch the function now. The period, the start says it starts at pi over 2. That is the line of asymptote, right? Because that was the line of asymptote when we set it to 0. So the first line of asymptote is pi over 2. So that's what we're going to do. Put in a line, pi over 2 as the line of asymptote. That's the line the curve approaches but never crosses. Right. The other line of asymptote is the next pi along. So which is 3 pi over 2, because that's what that says, the end of a period. That's 3 pi over 2. Right, so that meant we've got pi over 2 as the scaling, so if we have pi over 2, we add a pi to it, pi over 2 to it, we get pi. Pi over 2 plus pi over 2 is pi. So therefore, the point is going through here is 0 here. Now the graph of cotangent looks like that, but the minus is reflecting it. So instead of looking like that, it's rather going to look more like tan function, because that's what it's going to look like. So if we draw that from, and then the minus 4 here, 1 over 4 is saying the graph is now broad rather than just shallow. So it's slow. So the graph is going to go up like that. Okay, it's going to go a bit more like that, and then go approach. It's a bit broader, and then goes slowly there before it starts to curve in. So that's what the 1 over 4 is doing, because A is between 0 and 1. When A, ignore the negative, because negative is just reflecting along the x-axis, but when A is between 0 and 1, it will make the graph broader. If A is greater than 1, it will be slimmer, it will be faster. Okay, so this one is the negative infinity, and that will be positive infinity for the range for y value. And we could sketch another one to the left here. If this is pi over 2, the next one will have to be minus pi over 2, because it's pi difference, period. Which means I need to take away another pi over 2 from there, so that'll be 0. That's the next crossing. So it's going to go through 0, and it will come from here. So this is the line of asymptote here, minus pi over 2. Okay, so the graph will be coming from negative infinity, and then a bit slower, and then go all the way to positive infinity. So that's what these are the two periods. The first period is between, that's a pi period, and that's a pi period. And that's why we divide it by b, because the period is a pi. Y equals minus 1 over 4 cotangent x minus pi over 2. So let's talk about the range quickly. The range for this function here, the range are the y values. So range are the y values, and the y values is, we're going to say, well, it starts from, comes from the negative. We always write the less value first. So minus infinity, it's less than y, and it's less than infinity. So that's plus infinity. So it's coming from a negative to positive. So we always write the smallest value first, and then we write the y, and then the largest value. So that's how we write the range. But the domain is all real values of x except some boundary conditions. So we can say domain x is got all real values of x, with the exception when x cannot be equal to, first of all, you can pick which one you like here. So I'm picking pi over 2. So it's going to be pi over 2 plus pi n, because it's repeating every pi. So let's write it here for the domain. So the domain is x colon x for all real value. That means for collectively all real value. And but the condition is x cannot be equal to pi over 2 plus pi, because it's repeating every pi n. And that's the domain, and that's the range.